Today I am going to provide you some numericals on uncertainty principle, on group velocity and phase velocity, as well as on waves and oscillation. Waves on oscillations, questions are already provided to you. Go through them, do practice. Okay. So now we are going to derive. Actually, not derive, rather you can say better establish. Because Schrodinger equation cannot be derived. We are trying to establish it. We shall start with Schrodinger time dependent equation. We start with a free particle. As I have already told you, we will always prefer to represent the wave functions in complex form. And what is the advantage in that? That I have already explained to you people. If you go for a free particle, or a free particle, a free particle is one on which no force acts. So it has no potential energy. Its total energy is equal to its kinetic energy. A free particle is represented by a plane wave given by, we will do it for one dimension. We will only obtain this Schrodinger's equation for one dimension, not for three dimensions. So one dimensional wave equation at a point at t, the wave function for a free particle can be written as a to the power I. Either it can be omega t minus kx or kx minus small omega t, does not matter. Now differentiating both sides, with respect to t once एक बार, तो क्योंकि psi x और t का फंक्शन है, खाली t के साथ डेरिवेटिव करोगे तो दैट विल बी ए पार्शियल डेरिवेटिव. So this is equal to, because you have taken it t, so there will be minus I omega a to the power I kx minus omega t, which is equal to minus I omega psi. Multiplying both sides by I x cross. If you multiply both sides by I x cross, what you get? I x cross del psi by del t is equal to minus I square, I is root over minus 1, x cross omega psi, and I square is minus 1, minus minus plus, so x cross omega psi. But what is x cross omega? As we know, it is equal to total energy, which is also equal to kinetic energy for a free particle. So what you got is I x cross del psi by del t is equal to E psi. Whenever you will be asked to derive Schrodinger equation, time dependent Schrodinger equation in one dimension, you will proceed like this. Anywhere you are having problem, let me know please. इसको एक बार डिफरेंशिएट के टाइम के साथ तो आपको ये मिला, अभी उसको दो बार डिफरेंशिएट करो x के साथ, differentiating both sides with respect to x, but twice. So del square psi by del x square, x के साथ दो बार डेरिवेटिव कर रहे हो तो I के दो बार आएगा, and then it will be a to the power I x minus omega t, and this is equal to psi. So I square k square psi. Multiplying both sides by extra square by 2n. क्या मिलता है? Extra square by 2n del square psi by del x square is equal to I square is minus 1, so minus extra square k square by 2n into psi. So this can be written as, you see, but x cross k for de Broglie is equal to p, that you know. So you can write minus x cross square by 2n del square psi by del x square, यहाँ पे माइनस ले आया और ये हो गया p square by 2n into psi. बट आप लोग जानते हो p square by 2n is equal to kinetic energy non-relativistic limit, which is equal to total energy also for a free particle, because a free particle does not have potential energy. अगर यहाँ पे पार्टिकल फ्री नहीं होता, then I would have written for k d minus v. V is the potential energy. So for a free particle, if I go minus h cross square by 2n del square psi by del x square is equal to E psi. This is equation 2. You compare 1 and 2, their RHS are same. So because their right hand side are same, what you got from 1 and 2 is minus x plus square by 2m del square psi by del x square is I x plus del psi by del t. Mark, this is a differential equation whose solution will give you the time and position dependence of psi. So this is called as Schrodinger's differential equation. Schrodinger's time dependent. Why time dependent? Because the differential equation contains time within it. Time dependent differential equation. But for a free particle, because we have started with free particle, अगर पार्टिकल फ्री नहीं है तो if it is under the action of a force field, आप एक काम करो, इसको ऐसे मत लिखो, इक्वेशन 2 को k psi is equal to E psi करके लिखो. K is equal to E because for a free particle, but for a particle in force field, अगर पार्टिकल के ऊपर एक फोर्स आ रहा है, now the particle will possess potential energy. V, and this potential energy also may be a function of position and time. That is a possibility. Then square by 2m, which is equal to kinetic energy, that becomes total energy minus potential energy. So in this case, the expression 2 becomes minus x cross square by 2m del square psi by del x square is equal to E minus dxt whole into psi. So that you can write as this gives you minus x cross square by 2m del square psi by del x square plus dxt psi is equal to E psi. This is 3. This is for the case when the particle is moving under the action of a force. It is not a free particle. That you should remember. Then now if you compare 1 and 3, they are RHS subset. So for a particle in force field, you can write IH cross del psi by del t is equal to minus h plus square by 2m del square psi by del x square plus Vxt, where potential energy is a function of position as well as time into psi. This is the Schrodinger equation for a particle moving under the action of a force field. Schrodinger equation Schrodinger in fact time dependent equation because time factor is there. For a particle moving under the action of a force field. अगर आप लोगों को क्वेश्चन में पूछा जाता है कि स्क्रोडिंजर का टाइम डिपेंडेंट इक्वेशन डिराइव करो, क्या आप लोग कर पाओगे? अगर आपको किसी ने पूछता है कि स्क्रोडिंजर का टाइम डिपेंडेंट इक्वेशन को डिराइव करो,
यस सर।
क्या आप कर पाओगे?
यस सर।
ये जो स्क्रोडिंगर टाइम डिपेंडेंट इक्वेशन हम लोग निकाले ना, इसमें काइनेटिक एनर्जी को हम लोग स्क्वायर बाय 2m लिया है. So kinetic energy is equal to p square by 2m only when the particle is moving in non-relativistically. For relativistic case, this is not applicable. So Schrodinger equation has some limitations. These limitations can be noted like this. Schrodinger equation is applicable only to non-relativistic problems. स्क्रोडिंगर इक्वेशन को सॉल्व करके हमको वेव फंक्शन मिलता है, इसीलिए स्क्रोडिंगर इक्वेशन को सॉल्व करने के लिए पहले आपको पोटेंशियल एनर्जी के बारे में इंफॉर्मेशन होना चाहिए. तो मैथमेटिकल फॉर्म of potential energy dxt must be known from the beginning and then only Schrodinger time dependent equation can be solved to obtain wave function. Our aim is to obtain the wave function describing the matter waves. That is very important. Many times what happens, even if you know the potential energy function, but the differential equation remains in a shape which may not be integrable, so that a solution can be obtained. Our limitation is many times Vxt has such a state, such a shape that this Schrodinger equation cannot be integrated. Then analytical solution or wave function is not possible to get. So these are the few limitations. These are the cases where Schrodinger equation cannot be applied to reach at a result. Any doubt anyone is having regarding the derivation of Schrodinger time dependent equation? So if you have no doubt, this Schrodinger time dependent equation is applicable for all cases. Whether it is the electron revolving around the nucleus, whether it is the alpha particle approaching towards the nucleus, whether it is the electron who you are using to perform a diffraction pattern, everywhere, whether it is the electron who is moving inside a metal, whether it is the electron who is moving in a one dimension inside a one dimensional nanotube, in all these cases, if you want to get the wave function for the particle, what you need is you have to solve this Schrodinger equation. But for that reason, you have to know first what is the mathematical form of potential energy function. But very interestingly, there are the cases where this potential, what I have written, the potential energy is a function of position and time. Many times we deal with the situations where the potential energy is not a function of time. There are many situations where the potential energy is not a function of time. In all those situations, you can use the partial, separation of variable method. Because look at this particular equation, it is a second order partial differential equation. Look at that. And many times second order partial differential equations can be solved by separation of variable method. But that happens only when the coefficients, they are not the function of both the independent variables, whatever you are adapted there. Now, if the potential energy is not dependent on time, in that case, you can mark all these coefficients. They do not. They do not. They are not the functions of both x and t. Either the coefficients, they are function of x or they are constants. So in that case, you can use the separation of variable method to reduce the problem further. To reduce the mathematical complexity. Then what is interesting is, you will see that if the potential energy is not dependent on time, the time part solution can easily be obtained. And the space part to get, you have to solve a differential equation which is not partial, but an ordinary differential equation. That is what we call as Schrodinger time dependent equation. So we are heading towards time independent equation. Schrodinger time independent differential equation. Mark, it is time independent. Why I am saying this? That will be very clear. In many situations, the potential energy function Vxt V is independent of time, but that may depend on position. That is del V by del T is equal to 0. So in that case, V which was assumed to be a function of position and time now becomes a function of x only. Then Schrodinger time dependent equation becomes I x cross del psi by del T minus x cross square by 2m del square psi by del x square. In place of V it is dx only, not T. Sorry. So you can mark here the coefficient is I x cross, here the coefficient is minus x cross square by 2m. These two coefficients are constant. And the third coefficient is dx, which is a function of x only, not a function of t. In this case, you can use separation of variable method to separate out the space part and time part of the solution. We can use separation of variable method to solve this differential equation. Let us assume psi, which is a function of x and t, to be product of a function of x only and a product of function of t only. Such type of assumptions is possible only when the coefficients are constants or it is a function of only one independent variable. This gives me I x cross del psi by del t, I x cross del by del t of I x into ft. Now phi x is independent of t, so that can be treated as constant. I x cross phi x into del f by del t. Similarly, if you go to minus x cross square by 2m, del square psi by del x square, you see psi is a function of both x and t. You see psi is both function of both x and t. So if you take this minus x cross square by 2m, del square by del x square, I x into ft. So this is equal to I x comes out minus x, sorry, ft comes out x cross square by 2 because it is a derivative with respect to x, whereas t is independent of x. So del square phi by del x square only. Then Schrodinger टाइम डिपेंडेंट इक्वेशन इसको अगर आप को बोलते हो, then Schrodinger टाइम डिपेंडेंट इक्वेशन को becomes LHS हो गया I x क्रॉस I x del f by del t, RHS हो गया माइनस h प्लस स्क्वायर बाय 2m ft del square pi by del x square plus vx ix into ft because psi s is equal to phi s into ft. Now you divide both sides, dividing both sides by product phi s into ft. If you divide both sides by the product of ix and ft, what you get? In LHS, there is a phi s. So when you divide this, phi s will be cancelled. So what you shall see, ix cross 1 by ft del ft by del t. In RHS, your ft is there, ft will be cancelled. So one x will be there minus x plus square by 2m 1 by pi x del square pi by del x square. These pi x and ft will be cancelled by dividing, so only it will be dx because d is a function of x only, not a function of t, as we have discussed. Now you just mark the LHS is a function of t only, there is no x part. The RHS is a function of x only, where x and t are independent variables. This is possible when both sides is equal to a constant. The LHS is a function of t only and is independent of x. The RHS is a function of x only and is independent of t. As x and t are mutually independent, this is what you see in partial separation of variable method in solving partial differential equation. And this equality is possible only when both sides are equal to a constant. Let us take that constant to be E. Then Ix cross 1 by ft del ft by del t minus x plus square by 2m del square pi by del x square, where pi is a function of x only, plus dx is equal to E, where E is a constant. Of course, this is equal to the total energy. So what you got is, you got two differential equations. Ix cross, because this is a constant, so you can write this partial derivative as a total derivative. dft by dt is equal to E. So you can write dft by dt is equal to E by Ix cross ft. Take this as 5. Other point, is minus h plus square by 2n d square phi x by dx square plus dx is equal to E. Of course, here there will be one prime. That means minus x plus square by 2m square pi x by dx square is equal to e pi s. Oh, sorry. Plus bx ix e pi s. This is 6. This equation 6 in fact is called now Schrodinger time independent equation because there is no time independent part. This equation 6 is called as Schrodinger's time independent equation. Its solution gives you, इसका solution क्या देगा? Gives us pi x, which is only the space part of complete wave function.
Yes, sir.
तो इसको सॉल्व करोगे तो आपको खाली फाइव एक्स मिलेगा और एफ टी द टाइम पार्ट एफ टी इज ऑब्टेन्ड by solving equation 5. So now you are having two differential equations, one to get the time part, another to get the space part. Multiply them and then you will get the complete wave function. Equation 5 can be written as dft by ft is equal to I e by sorry e by I h cross dt, जिसको आप चाहो तो माइनस आई बाई एच प्लस dt भी लिख सकते हो। एक ही बात है, ऊपर आई मल्टीप्लाई करोगे नीचे आई मल्टीप्लाई करोगे। Then integrating both sides, what you get is integrating both sides integration of dft by dt minus I by h plus integration dt. Now you know LHS is nothing but the logarithmic of ft. You know how to integrate such type of integrations. So this gives you log e ft minus I. Of course, here you can take a constant. इंटीग्रेशन करने के बाद एक कांस्टेंट होता है ना, उसको log e c ले सकते हैं जो कांस्टेंट। Then you can easily write log e ft by c is equal to minus I by h cross into t. So what you get is ft by c is equal to e to the power minus I by h plus into t, and ft is equal to c to the power minus I by h plus into t. So of the order e to the power minus I by h plus into t. This 7 is the time part. Seven gives the time part of wave function when potential energy D is independent of time. So phi x is obtained by solving C and Ft is given by equation 7. So if you combine them, you can get the complete wave function, and the complete wave function is psi xt is equal to phi s e to the power minus I by h cross into t. This is the complete wave function when the particle is moving in a region where the potential energy is independent of time only. This is the complete wave function when the particle is moving in a region where potential energy is independent of time. So this is what you have to do to get the Schrodinger time independent differential equation. In fact, the time independent differential equation is minus h cross square by 2m d square phi by dx square plus bx into phi x is equal to e phi x. And if you solve this, you get phi x. You need not have to get ft because you have already obtained that eft. So in the cases where the potential energy does not depend on time, you need not have to solve the Schrodinger time dependent equation. You can solve the Schrodinger time independent equation to get the space part of the complete wave function because the time part of the complete wave function is already obtained here. And then multiplying both of them, you can get the complete wave function. I don't know how far you could understand, but both of these treatments are too long questions. Many times the question comes to derive the Schrodinger time dependent equation as a long question for 8 or 10 marks. Many times it is asked to get the Schrodinger time independent equation for 8 or 10 marks in the form of a long question. Any question from anyone? Yes, any doubt? क्या रे सो गए क्या?
नो सर।
नहीं सर।
सब चुपचाप हो गए? समझ में आ रहा है या नहीं?
तो आ रहा है सर। यस सर।
तो अगर स्क्रोडिंगर इक्वेशन को डिराइव करो बोल के ऐसा आता है, टाइम डिपेंडेंट हो या टाइम इंडिपेंडेंट हो पाएगा?
यस सर, होगा सर।
ये स्क्रोडिंगर इक्वेशन को थोड़ा केयरफुली मार्क करो तो देखो, ये टाइम के साथ फर्स्ट ऑर्डर है और स्पेस के साथ सेकेंड ऑर्डर है। जबकि आप अगर याद करोगे जो क्लासिकल वेव इक्वेशन था वो स्पेस के साथ भी सेकेंड ऑर्डर था और टाइम के साथ भी सेकेंड ऑर्डर था। ये सबसे इंपॉर्टेंट बात है स्क्रोडिंगर इक्वेशन का। दूसरा इंपॉर्टेंट बात है स्क्रोडिंगर इक्वेशन का कि स्क्रोडिंगर इक्वेशन मार्क करो एक लीनियर डिफरेंशियल इक्वेशन है और लीनियर डिफरेंशियल इक्वेशन का एक इंटरेस्टिंग प्रॉपर्टी होता है कि उसका जितने सारे सॉल्यूशन निकलेंगे वो सभी सॉल्यूशन को ऐड कर दो, रिजल्टेंट भी एक सॉल्यूशन हो जाएगा। दैट मींस द सॉल्यूशंस ऑफ द स्क्रोडिंगर इक्वेशन परमिट्स द सुपरपोजिशन प्रिंसिपल। तीसरा जो इंपॉर्टेंट बात इसमें आप देख रहे हो कि ये स्क्रोडिंगर इक्वेशन एक कॉम्प्लेक्स डिफरेंशियल इक्वेशन है, इसमें आई इन्वॉल्व है। तो ऑब्वियसली इसका सॉल्यूशन भी कॉम्प्लेक्स होगा। Whereas आप अगर क्लासिकल वेव इक्वेशन जो वेव चैप्टर में हम लोग डिस्कस किए थे, आप उसको याद करो, तो उसमें कोई इमेजिनरी टर्म नहीं था, वो कंप्लीटली रियल डिफरेंशियल इक्वेशन था। स्क्रोडिंगर इक्वेशन का सॉल्यूशन अलग अलग सिचुएशन में, जिस केस में पोटेंशियल एनर्जी अलग अलग है, वो सभी अलग अलग सिचुएशन के लिए अलग अलग होगा। ये कुछ इंपोर्टेंट पॉइंट्स हम लोग नोट करके रखेंगे स्क्रोडिंगर इक्वेशन के बारे में, एंड हाउ इट इज डिफरेंट फ्रॉम द क्लासिकल वेव इक्वेशन। Classical wave equation is second order in space, second order in time. Schrodinger equation is first order in time and second order in space. Classical wave equation is a real differential equation. Schrodinger equation is a complex differential equation. Schrodinger equation only is applicable to get the matter waves wave function. बाकी जो प्रॉपर्टी है ना, दोनों सभी वो माने कॉमन है। फॉर एग्जांपल दोनों डिफरेंशियल इक्वेशन लीनियर है, वहां पे डिफरेंशियल इक्वेशन को लिखने के लिए आपको वेलोसिटी चाहिए, यहाँ पे डिफरेंशियल इक्वेशन को लिखने के लिए पोटेंशियल एनर्जी चाहिए। सो ये जो कुछ बातें हम पीपीटी में मतलब पीडीएफ में दिए हैं, वहां पे भी उसको डिटेल्स में लिख दिया है, ये केयरफुली मार्क करना। नाउ वेयर we wanted to get the wave function to represent the matter wave. We found that wave function is a mathematical quantity which cannot be measured directly because it has no physical significance. Then how to get the wave function? The answer was given by Schrodinger equation. Schrodinger equation told that you just take my differential equation. For that particular situation, you find out the potential energy. Then you solve this differential equation, you will get the appropriate wave function. तो वेव फंक्शन को निकालने का एक ही तरीका है, वो है स्क्रोडिंगर इक्वेशन को सॉल्व करना। कोई दूसरा रास्ता नहीं है। ये सबसे इंपॉर्टेंट बात आपको याद करके रखना पड़ेगा। एनी क्वेश्चन ऑन दिस? If you don't have any question, I can stop the class.
Yes sir, you can stop it.
ओके बाय। 3 बजे आप लोगों का प्रैक्टिकल है ना? आज कौन सा प्रैक्टिकल होगा
सर? फिर 6th प्रैक्टिकल सर,
पॉइजन्स रेशियो।
पॉइजन्स रेशियो।
ओ वो तो इजी है।
हाँ सर, तो जल्दी खत्म कर देंगे सर।
देखो तुम लोगों के ऊपर डिपेंड करता है। बाय।
यस सर, थैंक यू सर। बाय।
ओके सर, थैंक यू सर।
Thank you, sir.
यस सर।